Good morning, everybody. Welcome to the last episode, woo, of Intro to Space. Today, I'm just going to be trying and discuss the research that has been done in Space Lab, my research currently, and a few others. So I'm going to try my best to discuss my research. I've tried quite a number of times to a few people, and sometimes it's a bit, I'll try. So the picture that you're seeing in front of you first is the UCT satellite test bench. So this is basically a satellite simulator. And in that satellite simulator, you can model all aspects of the satellite. So just to give you a general background, usually satellites are separated into two groups, both hardware and software. So the hardware is the actual, maybe the camera or the battery or the onboard computer or the solar panels, that type of hardware. And then the software part is the actual software that runs on the onboard computer. So that actually does all the executions, whatever language, usually C++. If any of you know that, that's the language that's usually done for onboard flight software. So what happens here with the satellite test bench is there's a ground station. Usually there's a physical ground station somewhere within the country. So here we model the ground station. So we can actually send commands and receive data from the satellite. That's basically we're modeling the ground station. And that is connected to the satellite and orbit simulation. So one part of it is the space environment is actually modeled. So where the satellite is actually going to be placed in space, we model that environment. And the other part is we model the satellite. So the satellite is broken down into hardware and software. So what happens is we need to build the software for the hardware. But the hardware, because space, everything is unique, the hardware usually takes 12 to 16 weeks to build and then send to us. We can't wait that long while we're building the hardware because we usually have usually the satellite has to be launched within 2 to 3 years. So you can't wait for 12 to 16 weeks just to start writing the code. So what happens is you ask the manufacturer to give you the data sheet for the hardware, and then you model the hardware as best as you can. And then from that modeled hardware on the simulator, you can then build the flight software that can control that hardware, or the simulated hardware, should I say. But then when you actually put the satellite together, you can actually remove the simulated hardware and actually put the actual hardware. And now you have the code on the flight software that actually can control the actual hardware of the satellite, of the component. So that's what we have here. And other aspect, when you see onboard software development, that's the actual onboard software, all the controllers, nooks and crannies that allow you to send command or receive the commands, execute them, and then send the data down to the ground station. So all aspects of the whole space system is modeled on this test bench. I think that's best as I can say it in my head. And so the satellite is modeled, the orbit is modeled, the ground station is modeled. Then if all comes together, when you actually put it in, actually build the actual satellite, you take the onboard software that you've developed and you actually put it in the actual satellite, and then everything should run with a few changes here and there. And now you have your fully completed satellite within 2 to 3 years. That is the general understanding. So this satellite test bench or simulator was obviously sponsored by the people down below, and UCT now has one. So my research essentially focuses on developing a satellite that could be used for the African Resource Management Constellation, the second generation, should I say. The first generation is going to launch next year, the South African version. There's like 4 countries that are involved, and South Africa is one of them that's building their own satellite that can be used in that constellation. So my research now focuses on adding, let's say, a propulsion system and a South African built camera to that satellite. So because I was the first one to use this system, there's actually no real model of the actual satellite that's being built in South Africa. So what happened was I had to use a flying laptop. That's called the flying laptop satellite. and I'm now adding my subsystems or my parts to it, to that satellite, so my camera and my propulsion system, to prove that in the next generation for the African Resource Management Constellation satellite, we can add a small camera, because the camera is quite small. It's normally meant for small satellites, and we can add a propulsion system. So the propulsion system will help it keep within orbit. So what happens is satellites actually come down. So you launch them into a particular orbit, let's just say 700 kilometers. And over time, due to drag, atmospheric drag, it actually lowers the orbit because it slows down. So what happens is the propulsion system then activates and pushes the satellite's altitude back up to its normal orbit. So it might drop from 700 to 650. Propulsion system kicks in and it brings it back up to 700. So that's what we want, or that's what I wanted for the next generation of the Constellation. And I think, yeah, that's all. That's my whole research.